Okay, so for this problem, again, I don't know what else you've watched, but for this problem, what I'm seeing I got to go back and get my pointer here, folks. Let me drag this down. Okay, I don't see any means, I don't see any standard deviations. I am seeing a percentage that's supposed to be the population percentage, and I'm seeing a sample of 170. So this is a situation where I'm dealing with a sampling distribution for sample proportions. And so some things to check off: is this a binomial experiment since it's proportion? So, well, let's see, it's 26% chance that any customer is a first-time customer, and that's independent from customer to customer. So the probability stays the same. Each trial is independent. I have a fixed number of trials of 170 orders, and it's a yes or no. Either yes, it's a first-time customer, or no, the order comes from not a first-time customer. Now, the only other thing we're going to check and make sure the sample size is large enough so the central limit theorem will hold. So 26% or 0.26 times 170, is that greater than or equal to 10? Well, 10% is 17, and we've got 2.5, better than 2.5 of them. That one checks. And then you're going to subtract the 26% from 100, or 0.26 from 1, and that's going to be 0.74. And that times 170 will also be greater than or equal to 10. So the central limit theorem works. We can apply the normal curve ideas to this. Which tells me the center of the sampling distribution is the population proportion, so 0.26. Then I've got to figure out the standard deviation, and the way you do the standard deviation is you take, here, let's do this right on my calculator. Well, I won't, I'll write it right here in case you haven't seen the other videos. So 0.26 times 1 minus 0.26, which is 0.74. I divide that by the size of the sample, which is 170, and then I take the square root, and that will be the standard deviation for this, or the standard error, depending on what you want to call it, for the sampling distribution. Here, let's turn this calculator on. So 0.26 times 0.74 divided by 170, and then I'm going to take the square root of that, and that's my standard deviation. 0.0336 is it 417,108? We'll put in all those decimal places. I guess it won't let me, will it? Nope, I'm maxed, so that's all I can put in. Then they're asking me what's the probability of getting between a sample with a sample proportion between 0.37 and 0.5. So I'm going to do between 0.37 and 0.5. And since, what I do, 0.37. Okay, since 0.37 is not even on the +3 standard deviation mark, I know that's going to be practically 0 since that's my lower bound. So I guess they're looking for 4 decimal places. So this says 0.005. Let's see what they're saying the answer is. They're saying 0.004. I don't know. It's probably a rounding issue with the applet, in which case you could use another applet or our calculator, second distribution, normal CDF. The low is the 0.37. The high is 0.5. The mean is 0.26. And the standard deviation is that 0.03361,641. That's probably close enough. And move the decimal point over 4 decimal places, would round that to 0.00. Wow, even that, did I type something in wrong? Because even that would be a little different. I'm wondering if I've got the standard deviation correct. Let me check. So 0.26 times 0.74 divided by 170. Then I'm going to take the square root of that. 0.03367. That might be the issue. 0.3364. Let's round that to 2. It didn't make that big a difference, huh? Let's see if I make it 2. I'd like to be able to get that answer. Well, I don't know if I'm going to be able to get exactly it, but that's what you do. You're trying to find the area in between. And for this one, basically it's 0. I wonder if will it let me do 0? Yeah, see, it is pretty small, and it did accept the 0. So that's the kind of thinking you have to do with this, and it is just a little bit of code that's trying to calculate it. So I hope hopefully that helps you answer the question.